One of the keys to learning new information is organizing it. And we're really lucky as chemists because we have one of the best cheat sheets ever created, the periodic table. So in early chemistry, there were a few experiments that chemists were able to do fairly easily. And they found when looking at elements that they could start classifying elements in a number of ways. Things like, is it something that could be found in nature uncombined with other elements? Were they hard or were they soft? Were they malleable, ductile? What happened when you hit them with a hammer? Did they react with water? Did they dissolve in water? And as chemists worked through a lot of these early experiments, they started noticing that they could group elements together in ways that made sense. And when they started looking at all of the elements in atomic number order, they found that there was a repeating pattern throughout. So as they explored this repeating pattern of properties, they ultimately put it together in the periodic table. Let's just pause for a moment to enjoy the beauty of the periodic table. It really is, I'm being silly, but it really is an amazing amount of information, all in a pretty compact form. And once you know how to use it, you can figure out an awful lot of things just based on where something lives in the periodic table. So first of all, just a little bit of definition here. Remember I said that they were grouping elements by similar properties. So the groups in the periodic table are the columns. So if we look in a group of the periodic table, things like beryllium, magnesium, calcium, strontium, barium, and radium have some similar properties. They are a specific group, and that's true all the way through the periodic table. The rows in the periodic table are the periods. So groups are columns, rows are periods, and that's where we roll around and repeat here. Let's take a look at some different ways that we can divide up the periodic table. One way we can do it is by looking at things that we call metals, nonmetals, and then that suspicious category in between, semi-metals. So on roughly a diagonal line here are the elements that we call semi-metals. And if we go to the left of that, we see things that are called metals. And this makes sense, right? You think about metal, what do you think about? You think about iron, you think about nickel, copper, zinc, gold, silver. These are all metals. Metals have a lot of similar properties. They often have metallic shine to them. They're often malleable, they can be hammered, ductile, they can be stretched. So those are metals. Now some of these are things that we don't typically handle as metals, sodium, potassium, a lot of the ones down here that are radioactive, but the physical properties are all similar. On the other side of that dividing line are the nonmetals. These are things that are not metallic. They don't necessarily have a metallic sheen. They're not things that are malleable, ductile, conduct electricity. They're things that might be pretty hard. If we think about something like diamond, a form of carbon is very hard. They might be pretty soft if we think about something like graphite, which is also a form of carbon. So on the nonmetal side, we can have much more varied properties in even within a single element like carbon. But we also have gases in here. So the properties of the nonmetals are much more varied, even though there are fewer nonmetals than there are metals. The semi-metals, again, on this diagonal line, are things that, to varying degrees, can display some metallic properties, but can also display some non-metallic properties. So they're kind of our chameleons. They change depending on their environment a lot more than the other ones do. We call those semi-metals, or sometimes those are called metalloids. We can also describe the different areas of the periodic table by looking at the type of electrons that we're dealing with in that area. So often this part of the periodic table is called the S block. This part is called the P block. This is the D block. And down here is the F block. The S and P blocks make up what we sometimes refer to as the main group, or the representative elements, they're also sometimes called. The D block are transition metals. So there are a few groups within here. There are things like the coinage metals and a few other groups. And then down here, the F block are also often called the rare earth metals. So just a little bit of vocabulary as you start working with different parts of the periodic table that you might come across. We can also specifically look at individual group names. I already mentioned things like coinage metals that are within the transitions, but this group 1 over here are the alkali metals, group 2 are the alkaline earth metals. When we move over to the non-metal side of things, these are probably a little bit less important to know the group names, but depending on your field, you might run into them. So the nitrogen group are the pnictogens. I always remember that one because pnictogen starts with Pn, and the first two elements in the pnictogens are P and N. Chalcogens are the oxygen and sulfur group. Halogens, that's one that you might run into a little bit more commonly, are fluorine, chlorine, bromine, iodine, that group of metals. And then this last group here are called the noble gases. These, for a while, were called the inert elements, but we've gone back to calling them noble gases because they're not really that inert. The heavier ones here can do some chemistry and form some chemical compounds. Fun little side note, the reason that these are called noble gases is kind of a little political dig at the noble class from old. Noble gases are big and just kind of tend to sit around and don't do much. So some scientists wanted to insult the nobles a little bit, so called these noble gases because they're just kind of sitting around and not doing much. So those are some of the group names that we might run into as we use the periodic table. Again, the periodic table is your totally 100% allowed cheat sheet. It's got so much information in it, and we're going to spend a little bit of time as we work through different topics talking about some of that information. One quick note, when we're talking about assignments in class, doing things in D2L, if you're doing the quizzes in D2L, always use the periodic table that is in the Start Here module in D2L. All of the questions are built using that specific periodic table with the specific numbers that are in that periodic table. So if you just pull numbers off of some random periodic table on the internet, it may have slightly different numbers that will possibly lead you to answers that will be marked incorrect in D2L. So there we've got it, the periodic table, chemistry's cheat sheet, and just a great tool for us to use for a lot of things. Good luck on that, and we will apply that periodic table a whole bunch in the upcoming videos.